Hello everyone, how are you? I hope you all are great, you all are doing very well in your life, and I think you all are enjoying. Okay, what we are going to do. As you can see on my screen, that it's a chapter Combustion and Flame, which is in your syllabus. So, we are going to study or we are going to start this chapter today. Fine, that is the Combustion and Flame. Okay, but first of all, I would like to introduce myself. So, my name is Arushi Sharma, and yes, I'll be a chemistry teacher. That's why I'm going to teach you combustion and flame because it's the chapter of chemistry only. So this is my brief introduction, first of all. Okay, thank you. So, this is my brief introduction. We are going to start with the chapter now. So, students, what the thing is that today we are going to discuss two topics here. That first of all, we are going to discuss here what's the combustion because the chapter is combustion and flame. So, we should know what is the combustion. And the second part, which we are going to study here, it is the conditions required for combustion. Okay, conditions required for combustion. Now this topic, like what are the conditions we require, we'll see it later. Okay, because first of all you should know what is the combustion, then you'll come to know that what are the conditions required for it. Okay, so before starting the chapter, okay, but on screen you can also see that this is the combustion. It is written here and you can see that one of the picture is here exactly. Oh, sorry, I'll just go that slide. Yeah, so you can see that this picture is involved here. You can see that these are the wood logs and you can see some fire is there, so you can relate it also, like whenever in the winter season, like it's going on right now. So in the winter season what happens that we usually what we use we like in some houses that people uses heaters, okay, that electrical heaters. But have you ever seen that some people are using wood for like firing purpose, not firing but for burning purpose, so that they can get heat from it. So yes, this is the example of combustion. But how it is an example of combustion, we'll come to know. Okay, see, now why I have given you this winter example, because what happens, like in winter there is so much cold outside, okay, but generally what happened that if we are not having electrical heaters, so we are having another option is that if you're having some wood logs or something which is made up of wood, or you are not using it, so what people do, like in my house, what happens that my grandmother, what she does, she like there is one table which is not of use, so what she did with it, she broke down it, and she uses that wood part, and she kept that wood part on fire, and from that what we are getting light. As you can see that when there is the burning process is going on, that flame is coming out, so from that flame what we are getting light. And along with that light, what we are getting heat also, because it's the winter season, it's cold there. So what happened that when there is the fire, so what we are getting heat from it. That's why it looks very nice to sit around it. Exactly, like you also have think about, I think you have heard about camping fire. Have you ever gone to camping fire? Even though I haven't, like I never went with my friends. It's just that I have just done camping fire in my house only. So what happened? We just together that wood logs and we just try to burn them by putting some kerosene oil over them or by putting some kind of things, and that's how they start burning, and we get light and heat from it. So now, why I'm telling you this example? Because student, combustion is that process only. Okay, first of all I'll just try to tell you about the definition of combustion, then I'll tell you that why I'm telling you this example. Okay, so combustion. Now if we talk about what is the combustion, so you can say that it is a chemical process. It is a chemical process in which what will happen, that it is a chemical process which occurs in presence of oxygen, in presence of oxygen. So student, never think about that if there is no oxygen, so that combustion will not take place. Even though, have you heard this thing, like I have given you this example that we gather wood logs in our houses, and then we do firing for burning process for that, so that we can get heat from it. And have you ever seen that what we do, that before doing that, we just try to, or just we come to, we just make that sure that the woods are not that कहते हैं ना कि भीगी हुई तो नहीं है woods. Exactly, that they are not, that they should be dry. It's not like that it is having some water in it, or that's, if there is water, so they are not going to burn. Exactly. So because if there is water and they are not going to burn, because what will happen, it will cut off the supply of oxygen to that fire process, and if there is no oxygen, so there will be no combustion. So exactly, student, combustion will occur only when there is the presence of oxygen. Okay, so it is a chemical process which occurs in the presence of oxygen. So just remember, it is a very important thing. If there is no oxygen, then there will be no combustion. And again, we'll come to know that exact what is the combustion is. Okay, so it is a chemical process which occurs in presence of oxygen, and what it produce carbon dioxide. I think you know this formula of carbon dioxide. It is the carbon dioxide, and in some cases you are getting water also, that is the H2O, along with heat and light. Heat plus light, like I have told you here, like whenever we do this kind of thing in our houses, why we do that? So that we get heat from it. So exactly, in that process we are getting heat and light also. So students, what you can think here, that what is the combustion now? See, combustion is a process in which any carbon compound. Now, why carbon compound? See, carbon compound, like when you are going to a class 10th, so you are having one chapter in your syllabus that is called as the carbon and its compound. Okay, yes, it's a very important chapter, students, because when you are going to study that chapter, what you'll find out, okay, that we human beings, even though plant bodies or like wood, everything is made up of carbon only. Okay, so when that, under in the presence of oxygen, we combust them, we give fire, or we burn that product. So what we are getting carbon dioxide along with heat and light. See, in this picture you can see that there is this wood. And what is wood? As I told you, that the wood is made up of what? It made up of carbon compounds. Okay, that means carbon. So that means carbon in the presence of oxygen, when it is undergoing the burning process, so what it will produce? It will produce carbon dioxide. In some cases we are getting water also, along with heat and light. It is very important that we are getting heat and light, and that is called as the combustion process, and that reaction is called as the combustion reaction. So if I tell you about the carbon, this is the carbon C plus oxygen. Okay, oxygen is gas which we are getting from our atmosphere, and then what we are getting carbon dioxide along with heat and light, along with heat and light. So student, now this reaction is called as the combustion process. What it is called as? It is called as the combustion. So now you'll come to know what is combustion. That in the combustion, the substance is burning, and it is a substance generally which is made up of carbon. Okay, so what we are getting in the presence of oxygen, we are getting carbon dioxide, heat and light. Okay, so this is the combustion here. This is the combustion process, and now this type of reaction is called as the combustion reaction. Okay, fine. So this is the combustion. Now, as you can see that we are getting heat and light. Now, students, there is very one important word in this definition, that if I want you to notice that word, because student, what happens that whenever we are getting any definition, so what happened that it always in a standard form, that it contains some very important word in it. So we have to focus on that word also, like in the presence of oxygen, that means if that there is no oxygen, that means there will be no combustion. Now the important word what you can see, it is the chemical process. Chemical process, student, it is a type of the process which is a kind of irreversible process. Okay, like if I give you one example, Okay, we'll take that example that whenever our mother cooks food for us, okay, so what she do, she take a flour, then she make a dog of it, and she then make chapatis from it. So are you able to convert that chapati again into flour? Exactly, no. So that process is called as the chemical process. So students, even though combustion is also a chemical process, that means you are not getting reverse of it. That means you are getting some changes after the reaction. Okay, like if I say that if carbon is there, so what will happen now? Carbon is converting into carbon dioxide. Okay, so that's how it is a chemical process. That means after the reaction you are going to see some changes there. Okay, so this is the you can say that what we can say, this is the combustion. Fine. Okay, now like I have told you that we are getting some chemical changes here. There should be some chemical change. Okay, there should be some chemical change after the reaction. But see, student, we are getting in this case heat and light. But if I ask you that we are having so many things in our daily life from which we get heat and light, so all those type of reactions are combustion reaction. Can you think of it? Just try to think about it. Like in this reaction, we are getting heat and light along with carbon dioxide. But can you think about it that all the other type of process which are going on and which are providing heat and light, so they all are the type of combustion process. Okay, so I'll tell you. See, if for example, I'll take one example here that if we are why we use tube light or bulbs to get light. Exactly. So what happens is whenever we turn on the switch, so what happens? The bulb starts glowing. Okay, so when it starts glowing, so what happened? Like after some time, when start glowing, or for after that 10 or 15 minutes, so what you find out that bulb start heating also. From that you are getting some heat also. Like if by chance you touch that bulb, you feel some heat and you'll take off your hand from that bulb. Exactly. So in that case also you are getting heat and light. So tell me that, so just try to understand that that the glowing of that electrical bulb is also a combustion reaction. Is also combustion reaction. Try to think it like if we are having one electric bulb and it is also giving heat and light. Like in the in the combustion process, what we require heat and light only. Okay, like what we are getting heat and light. So electric bulb is also giving heat and light also. So whether the electric bulb can also be a combustion reaction here? No. So the answer for this question is no. It is not a combustion reaction. Why? Because students, like I have already told you that it is a chemical change. It always requires some chemical change. For example, if we take an example of coal, koila, so that coil whenever it burn in the presence of oxygen, so that coil convert into ash. Exactly, that means the composition is changing here. But in the case of electric bulb, what you are seeing, that bulb is not going to convert into anything. It's just that when you are going to turn off the light, it just get turned off and you are not getting any heat or light from it, and you are not getting any other product also. Exactly, so it is not a combustion reaction. Not combustion reaction. So students, always remember whenever there is a combustion reaction, whether we are getting heat and light, there should be some chemical change. For example, I have given you example coil and ash also. Exactly. Like if sometimes have you seen that whenever any person died, so whenever we like in okay, what happened that if that person is getting burned or something else, so what will happen, that body convert into ashes, not is just like that, there is no convert. So that is the like why I have given you the example of body, because I have told you it is made up of carbon compounds. Okay, so this is the combustion reaction, student. Okay, so like in this case also there are some wood logs, and then wood logs are getting burned in the presence of oxygen, and we are getting heat and light from it, and there will be release of the carbon dioxide in the atmosphere, because carbon dioxide is what? Carbon dioxide is a gas. Okay, it is a gas, so it will release into the atmosphere. Fine, got this point? Okay. Now, like we have discussed also difference between that whenever you will say that ma'am whether it will be a combustion reaction or not. So now what you have to observe that if it is having some different, like if it is, if its composition is not going to be changed, then it will not be a combustion reaction. For example, electric bulb, or you can take the example of tube lights also, from which we are getting heat and light as well. Okay, so what we require chemical change. Fine. Now, students, like if I ask you one, not one, like I have already given you so many example, like carbon and its compound. See student, like carbon compounds is just that we are having carbon compounds each and everywhere, even though our human body is also made up of carbon. Okay, coil is made up of carbon, wood is made up of carbon. Okay, so that's how student, carbon when combines with oxygen, it converts into carbon dioxide, which along with what we are getting, heat and light, that is the combustion. Okay, so there is one important, not important, we can say that there is one example of CH4. This is called as the methane gas. Okay, this is called as the methane gas. So when this methane gas is combust in the presence of oxygen, it is also a gas again, because we are not providing oxygen to it. What we are providing it, we are providing is just, we are methane can be called it as fuel. Yeah students, so there is a new introduction, new word is introduced here, that is the fuel. So you can say that this is the requirement for combustion. If we are not having such type of material which can undergo the combustion, so combustion can occur. No, so that's why we require such type of material which are that are combustible in nature. So that type of substances are called as the combustible substances, or we can say that fuel. So when there is fuel and we are having oxygen in our air, so what will happen, it is going to convert into carbon dioxide along with H2O. Like I have already written that in some cases we are getting H2O as well, and plus light and heat. So this is the combustion reaction now. Okay, so now it's your task again now, that you'll tell me some of the example of combustion. That not example, or you can say that, like I have told you, combustible substances. Okay, so students, now here again a new word comes up, that is the combustible substances. So what are the combustible substances now? Like from word we can easily conclude this, that what can be a combustible substance, that the substance which can undergo the combustion, exactly, that which can undergo the combustion process, that is called as the combustible substances. Substances undergoing combustion, they are called, that is, they are called as the combustible substances. Okay, now as I have told you some of the examples here already. Like example, I have given you one of the example is the wood, which you have seen in the picture. One I have given you of the coil, that the coil is made up of the carbon and it convert into ashes when we provide some burning like when we provide a fire to it, so it converts into carbon dioxide, and along with heat and light is there. So it is wooden coil. Okay, now what else can be the example of combustible? Like you are providing them, like you are providing them fire, and it is, yes, they are burning. So student, there are some of the example also, that is kerosene, petrol. These all are also a carbon compounds only, that they undergoes the combustion process, and we get carbon dioxide and heat and light also from it. Paper is there, candle is there, exactly. Just a second. Candle. Okay, so yeah, candle is there. Because what happened when you like whenever we use candle, what happened that start glowing, we get light from it. Like some like nowadays we are having inverters, we are having generators to, like whenever there is power cut, so we can use them. Okay, but what happens generally, or some or nowadays also when we go to some village area where is not that much but nowadays villages are also developing, it's not like that. But sometimes it happens, even though it happens with us also, that when that our inverters goes down and we are having power cuts, so we are not having electricity in our houses. So what we use candles so that we can do some kind of work. Exactly, because what we are getting light from it. Okay, we are getting light, and even though what we are getting heat also, because you can't touch that candle, you just touch it wax, so you can't touch that flame which we are getting in the case of candle. Okay, and even though that candle wax is converting into the liquid part. Exactly, so that is how, student, we can say that these are the combustible substances which can undergo the combustion. Okay, now coming to the next part, that we can say that next part is the non-combustible substances, or you can say that that the substances. Now from the non-combustible, what you can remind easily that the non-combustible substances are those substances which are not undergoing combustion process. For example, students, so what example we can say that like stones, we are having glasses which do not undergo combustion. Have you ever seen that whenever any glass catch fire easily, or you seen that the glasses are catching fire and you are getting heat, and they can get, but it will require more and more of efforts. Okay, because the student, like I have already told you, these all are carbon compounds. Okay, but if we talk about glass, so student, glass is made up of silicon. I'm just trying to give you more and more knowledge. Okay, so that's how, if there is the silicon, so it will not undergo the combustion process. Okay, so that's how these are the non-combustible substances which are not undergoing the combustion. Okay, so I think I have pictures also here. Okay, I'll just show you once again here. Okay, so these are the combustible substances. You can see that the LPG, the cylinder which we are having, that the cylinder is having what? LPG. So that LPGs are also combustible in nature. Like if you remember that whenever we go for outings for 3 or 4 days, so it's our duty, not our duty. It's our mother who just take care of it. That whenever we are leaving her house, she turned off that knob of that cylinder, because student, it is very harmful if the gas is leaking, if the LPG is leaking, and if someone is giving some fire or you are using some fire near to it, so what will happen, it will convert into the explosion, because LPG undergoes the combustion process very fast. It will take just a minute, and not a minute exactly, it will take a few seconds, or it is just a process, and it would convert into a very combustible process. So that's how, student, whenever we are leaving for 2 or 3 days, or even though, like if we are going somewhere, so we should turn off that knob, because sometimes it happened that by chance, if there is some hole in the gas pipe, there is some leakage, and it will be harmful for everyone. Okay, there will be explosion and it will harm us. So that is how LPG is also a combustible substance. Paper, you can see. Now paper, I have already given you the example. Oil, so now oil, like I have tell you about the kerosene oil, petrol. Exactly. So these are the examples of combustible substances. So till now, what we have done? We have done combustion. That what is the combustion process? Exactly. And like I have told you also, like you can also think about it, that whether every type of the substance which is giving heat and light, it can undergo the combustion, or it can be a combustion reaction. We have discussed also. And even though we have discussed combustible substances and non-combustible substances. Fine, students? Okay, now coming to the next topic of today's class. So the next topic is that the conditions which we required. Conditions required for combustion. Okay, so like I have told you about combustion now. So can you think that what are the requirements for the combustion? That what we actually require so that there will be some combustion or we are getting some combustion process. Think about it like what we require for combustion. See, like from the definition only that the very first point that the combustion always takes place in the presence of oxygen, but before oxygen what we require, okay, oxygen we are having everywhere, exactly students, like oxygen we are having everywhere because oxygen presents in our atmosphere. So it's not like that at my house we are getting oxygen and at your house you are not getting oxygen, because oxygen we require for breathing purpose also, exactly. So we are having oxygen everywhere, but why everything is not getting combustion, like why everything is not undergoing combustion? Okay, because there are three type of requirements for it. First of all, it should be a combustible substance. You will say that, ma'am, you said that we human bodies are also that we are also carbon compounds, so why we are not getting undergoing the combustion process? Because we are getting oxygen and oxygen, exactly. But student, for that we require one ignition temperature. So I'll just write down some here points, that first of all we require one combustible substance which can undergo combustion. Okay, combustible substance should be there. If there is no combustible substance, so it will not undergo combustion. Okay, now one is the combustible substance, second one is the there should be proper supply of oxygen. Proper supply of oxygen should be there. If there is no oxygen, so there will be no combustion. Okay, I'll show you one picture also related to it. And the last one is the ignition temperature. Now you'll say that, ma'am, this is the new word and I'm not getting it what it is, so don't worry about it, I'll tell you. Okay, so it is the ignition temperature. Okay, so one by one we'll complete these requirements which we required for combustion. Okay, so, first of all, the first point is the combustible substances, and we have done with it. Like the substances which can undergo the combustion, that are called as the combustible substances. And I have shown you picture also here, that see, the condition is that we require combustible substances. And what are the combustible substances? You can see that which can easily undergo the combustion. For example, LPG, for example, paper, oil. Now you'll say that, ma'am, why they are going? So it depends upon the ignition temperature, and I'll tell you that what is the ignition temperature. Okay, now if I show you the next picture, because this is the first requirement, that first of all we require one combustible substance. Now the second one is that there should be proper amount of oxygen. So student, in this picture you can see that the candle is there. We have taken two candles, and one candle is, or you can say that we are having one candle, before that we haven't put the jar over it. Okay, so it is burning candle is there. That means there is proper supply of oxygen. Now, when we have put a jar over it, so what you'll find that after some time, that means the oxygen which is present inside that jar, so that oxygen, when it will get consumed during that burning process, and when it is going to be completely over inside that jar, so what you'll see that there will be no burning of the candle, because now there is no supply of oxygen is there. If there is no supply of oxygen, so what you will find that the candle is not going to be burned. Okay, you can also do this thing at your home also, because it is not harmful, and even though it is not that much difficult to do. So so what you can do, you can take one candle, you just burn it, and after some time you just put jar over it, and what you'll find that after 1 minute or 2 minutes or 3 minutes, that candle will stop burning, because the oxygen which is present inside the jar has been consumed up for the combustion process, for the burning of candle. Okay, now there is no oxygen inside the jar, and if there is no oxygen, so there will be no burning process of candle. Okay, so that's how we require proper amount of oxygen. Fine. Now coming to the ignition temperature. Okay, because this is the third requirement, so we'll study about ignition temperature now. Now, what is this temperature, student? See, it's not like that we are giving heat and something is going to be burned easily. You seen that if we talk about coil or kerosene or petrol, everything is having different temperature at which they start burning. Exactly. So that's how, student, ignition temperature, you can say that it is that minimum temperature. It is the minimum temperature minimum temperature at which substance catches fire. Substance catches fire. Okay, or start burning. Or you can say that minimum temperature, that is the lowest temperature at which the substance is going to be start burning, or either it is going to catch fire. So student, sometimes it happens like even though petrol is there, or we can say LPG is there, that if there is some if we are using matchstick or something else, that it can create fire there, so they just like suddenly they will catch the fire. Why? Because their ignition temperature is very low. If the ignition temperature is very low, that means that substance is going to catches fire very easily. That means it can undergo the combustion process very easily. So we require such type of substances which are having minimum temperature, so that they can catch fire. And if they are catching fire in the presence of oxygen, so what we are getting? We are getting heat and light from it, and we are getting carbon dioxide as well. So you can see that what is the ignition temperature? Ignition temperature at which substance catches fire or start burning. That means it would be that lowest temperature for that particular substance. Okay, so important thing is lowest the ignition temperature. Okay, so I'll just write down, it is the full form of ignition temperature, IT. Okay, so lowest the ignition temperature, so what will be required? It will catches the fire easily. Catches fire easily. Or that means, student, if its temperature is low, that means we would not have to give more and more heat, so that it can catch fire easily. Exactly. So less amount of heat is required. See, student, what happened na, that if something is going to be that if combustion process is going on, that first of all we have to give some heat. That's how the burning can start na. It's not like that okay, there is wood and it is getting and in the presence of oxygen it is undergoing the combustion. It's not like that. We have to give something like that, like we use matchstick or something like that, so that it starts burning. Okay, so that means if there is the lowest temperature is there, ignition temperature is there, so we don't have to give more and more heat so that it can catch fire. If there is lowest ignition temperature, we have to give less amount of heat only. Okay, everyone is clear with ignition temperature, that what is the ignition temperature? Okay, now I'll show you now this point here. Okay, now in this table, can you see that there is petrol? There are many things are there, and we know that each and every material that which is a combustible substance, they all are having different temperature. It's not like that everything is having every like same temperature. So that's how, student, the petrol, kerosene, diesel, wood, coil, piece of paper, they all are having different ignition temperature. So you can see for petrol, it required 246 degrees Celsius. That means its ignition temperature is this. That means we have to give that much of heat, so that its temperature will reach to 246, and and at that point, at that 246, it will start burning. Okay, and the kerosene, it is the 220 degrees Celsius. That means we don't require that much heat that we are requiring for petrol, because its ignition temperature is low. Exactly. And you can see the lowest one is for the diesel. Diesel is having 210 degrees Celsius. That means this is how ignition temperatures are variable. It's not like that everyone is having same temperature. Their ignition temperatures are variable, and we can see that which one is having more and which one is having less. See, for the coil, you can see it is 454 degrees Celsius. That means in this case, if its ignition temperature is very high, so we have to give more and more heat, so that the temperature will reach to 454 degrees Celsius, and at that temperature that coil starts burning, or that coil catches the fire easily. Okay, got my point? Like piece of paper is 233 degrees Celsius. That means first of all we have to reach that temperature, and at that temperature that particular substance will catches the fire and it will start burning. So students, like if we talk about LPG or if we talk about kerosene, so these are the some kind of things. Even the petrol is 246 only, that is not that much difference between petrol and kerosene. It's just that coil is having very high, it is 454, which is very there is a high difference between these two, like 200 something differences there. So like if we talk about petrol and kerosene, just a second, like if we talk about petrol, so petrol is having how much of temperature, like I have shown you already. So petrol will require 245 degrees Celsius, whereas kerosene will require only 220 degrees Celsius. That means that the ignition temperature of kerosene is less. Like if I show you here that the ignition temperature of kerosene is less than the ignition temperature of petrol. That means it will require less heat. It will require less heat, and it will catches fire easily as compared to petrol. Catches fire easily. Okay, so that's how ignition temperature works, that the substance which is having more ignition temperature, it will require more and more heat so that it can convert into carbon dioxide along with heat and light. So everyone is clear with ignition temperature? Okay. Yeah, because I'm having one video also. Okay, I'll tell you. Just a second. Okay, so what is there? Okay, so yeah, I am having one video. So do you like to see that video? Okay, so just a second, give me a minute and I'll just show you that video also. Okay, just give me a minute. Because I have already searched that video for you and I just want to show you that video so that you can come to know that how ignition temperature works exactly. So just a second. Okay, yeah, there is the video. Okay.
Okay, so this is the vent bung out of a 55-gallon oil drum. I'm going to put some kerosene into it.
Yeah, please listen it carefully. See what he does, that there's some instrument he has taken and he has put some kerosene over it. Okay, now
Kerosene isn't very volatile, so if I try to light it, nothing happens. Okay, so
now what happened, that he gives some fire to that kerosene and that kerosene is not taking not catches fire very easily. Like he provided that burning to it, that burning process to it, but it didn't get catch that it didn't convert into fire exactly. So just look at it.
Is I'm going to get a piece of fiberglass roofing insulation, make it into a wick. And I put that into the oil, it soaks up into it. There's a lot of fibers in the insulation, so there's a huge amount of surface area. So there's plenty of opportunity for the oil to vaporize. So when I light it,
so students, now can you observe, now when he used that wick, so when he put that wick over that kerosene, so when he give light to it exactly, so that wick exactly catches the fire. Like, so it's not like that it taking some time like the kerosene was taking. So it depends upon its ignition temperature. That means wick is having lower ignition temperature, that means it is catching fire very easily. But if we talk about kerosene, kerosene is having more ignition temperature than that wick. That is why it is not catching fire easily. Even though if we providing the heat for longer time to that kerosene, it will catches fire. But it's just that I want to clear the doubt about ignition, that how it works. So I hope after watching this video your doubt will get cleared. Okay, so these are the topic which we have to cover in today's class. Now there is one heading, you can say, not heading, but it's just that it is a very small topic, you can say, not a topic exactly. It is inflammable substances. Now what is the inflammable substances? So students, we can say that these are those type of substances that which are having the low ignition temperature, and they catches fire very easily, and that, like, when they catch fire, so they glow with flame. Okay, so that are called as the inflammable substances. So what we can write down for inflammable substances, that the substances which are having the low ignition temperature. And don't forget about it is what? Ignition temperature. Okay, so low it, and it is catches fire easily. Okay, catches fire easily with a flame. Don't forget about it, it is having flame in it, with a flame. And that type of substances are called as the flammable substances. Okay, for example, petrol is there. Petrol, you know na spelling for petrol? It is petrol, petrol. And what else? Even though in the case of LPG also we are getting flame. Okay, in case of candle also we are getting flame. So such type of substances which are having low ignition temperature, so that they catches fire easily, and they glow with flame, or you can say that they burn with flame. Exactly. Like students, as I told you the example of LPG. And even though I think you that we have heard this kind of news also, that somewhere that cylinder has got blast in that house. Exactly. So what happens that when there is the LPG leaked in that particular area, so and someone has provided some heat to it, and it just get explode. And what you see, that there is a boom kind of thing. Exactly. And what we can see, we see flame there. Okay, flame is there, so that we are getting light from it and from heat from it. Exactly. So that is the inflammable substances, that which catches fire with the flame. So that substances are called as the inflammable substances. Okay. Yes, student. So, like, we have done today what? Inflammable substances, conditions required for combustion, and what is the combustion. And student, don't forget about it, that for combustion there should be any chemical change, like in the case of coil is converting into ash. And this reaction, yeah, I'll just mark this reaction with some different color. Now this reaction is called as the combustion reaction. Okay, what we are getting carbon dioxide, water, light, and heat. And as I have told you, electric bulb is not the combustion reaction. Fine. So this is how we have done with our today's class. I hope you understand each and everything. And student, one more thing, like if you after listening this video, or after getting some points from it, maybe you are having some doubts in your mind. So what you can do, you are having one of the nice thing in the Ask IIT, you can say that you can post your doubt on forum. Exactly. And on that forum you will get your answers, so that you will not have to go here and there, so that you have to solve your doubts. You can post your doubt, whatever will be in your mind, you can post it there. Okay, and you will get to reply on it, and you will get your answer. Okay, students. And yeah, please study more and more, and we'll continue with our next session. Till then, bye bye. Thank you everyone for watching this video. Thank you.